Hey everybody, let's talk about volume today, and specifically let's just talk about volume of rectangular prisms. So you might recall that rectangular prisms are essentially a box, right? This is a cube, so all the faces have the same area. It has a front and a back, it has a top and a bottom, left and right, but we're not talking about the faces. When we talk about volume, we're actually talking about what's inside the box, or what's inside the prism. Now, as you know, boxes are made to hold things, and how much a box can hold is called its volume. It measures how much space is inside. You see all those cubes inside there? Well, that's how we measure volume. We count the cubes that are inside there. Let's look at it a different way, because it's important to remember, just because you can't see them from the outside, it's important to remember that those cubes are in there. And when we measure volume, it's all those cubes that we're trying to count. So when you can only see the outside, how do you count all those cubes that are on the inside? How do you find the volume? Well, let's take a look. An important idea is called the base layer. So here's a box, and it's really small. We can see that it's only 3 cubes wide and 4 cubes long. That's a total of 12 cubes. That's just the 2 dimensions. But as we add layers, we're going to use that idea that in one layer there's only 12. So in 2 layers, there's another 12, right? 12 on the bottom and 12 on the top. That bottom layer is the base layer, and as we add height, we just keep adding layers. That's 3 groups of 12, 4 groups of 12, 5 groups of 12, and so on. Each layer has the same number of cubes. Just because we can't see them, we do know that they're in there. And it all starts with counting that base layer. Okay? So let's watch it in action. Let's fill up the base layer of this box. We can see that it's 3 cubes wide, 3 cubes fit across the front, and 3 cubes long, right? That gives us a base layer. And what's the volume of that base layer? Well, you can just multiply the width times the length, and you see that it holds 9 cubes, right? And then we have to think about the height. So how many of those base layers will the box hold? And this box looks like it will hold 3, right? We're not told that, but it's a good estimate. So let's see, let's keep stacking. Okay, so there's 2 whole layers, but how many cubes are in that second layer? 9. And here's another layer. And how many cubes are in that third layer? 9. That's 3 layers of 9 cubes. That's a total of 27 cubes. Let's see that again. How many do you think are going to fit in this base layer? That's the width times the length. That's what gives us 9. So if we just measure, or multiply that width times the length, it gives us the base layer. And if we multiply that base layer by the height, it'll tell us the total number of cubes, right? Because the height is how many bases there are, how many base layers there are. So remember, when you're asked to find the volume of a prism, you're going to be multiplying the width times the length times the height. That's all 3 dimensions. Sometimes you're asked a question about something like how many basketballs can fit into a box. And you might think, well, I thought volume was cubes, but this is a volume kind of problem, right? So imagine that they tell you that a basketball has a 1 foot diameter. And so here's a box that's 2 feet by 2 feet by 3 feet. How many balls could fit in there? It's essentially a volume problem, right? You could see that we could fit 2 basketballs across one side, and then we could fit 2 basketballs across another side, and we could fit 3 basketballs high, right? So it's 2 times 2, 4 balls on the bottom, times 3, or 3 layers of 2. It's essentially a volume problem. So keep an eye out for these sorts of problems. You know that volume is measured in cubes, but boxes often hold other things. Okay, good luck with your volume problems, everyone. Bye-bye.